Welcome to our CSC420 project. We are Team AAA. I am Xinquan Yin.
I'm Yunfei Ouyang.
And I am Xu Tianze.
Today we are going to talk about our project on facial expression recognition.
Facial expression recognition is always a hot topic in the computer vision. The goal of facial expression recognition is to identify the different human feelings and matching them with different facial features. In this project, we would like to implement a neural network model and would classify images of faces into different facial expressions and do analysis on the performance of different methods.
The dataset we use for this project contains two parts. The first part is the emotional detection from facial expression from cargo computation. It contains 500 images of 5 facial expressions. All of them are of size 350 times 350. The other dataset we use is Multimedia Understanding Group Facial Expression Dataset. It contains 1,462 images of 6 facial expressions, all of size 896 times 896.
For the tools we used, the main libraries we use in this project are TensorFlow 2, Keras, sklearn, and OpenCV. We choose to use TensorFlow 2 and Keras is because this is a mainstream library to construct a convolutional neural network. sklearn is to provide classifier implementation for KNN and SVM. Last, we use OpenCV to modify our image datasets because it contains different methods, such as HOG and grayscale images. So for the methods we are using, we have 3 methods in mind for this project. The first one is a k-nearest neighborhood algorithm. KNN is a supervised machine learning algorithm that relies on labeled input data to learn a dataset and form decision boundaries. It is popular classification algorithm in the handwritten digit recognition. So I'm wondering that if I can use it in the expression recognition. Turns out I can. By setting a default feature vector from an image of the face, I produce the labeled digitized data where each is a Euclidean difference of the feature vector with the default feature vector. By doing this, KNN is able to generate good results.
The second method we are using is a convolutional neural network we learned in class. It is a deep learning algorithm that takes the advantage of unsupervised feature learning. The method we are constructing is based on the VGG16 neural network design, where we use different convolutional layers, the max pooling, to process the sensors, and then we use the dense layer to produce the outcome. The base VGG16 model we implemented produced convincing results.
Last, we are trying to build a support vector machine classifier because we believe it may produce better results when compared to the k-nearest neighbor. SVM is a supervised algorithm which is similar to the KNN. The goal of support vector machines is to construct hyperplanes to separate different sets of points, where in our case is to separate different facial expressions. We are still working on the implementation of the support vector machine. What we have done so far for the goals. Firstly, we gather data from online resources such as Kaggle. Then we processed those data into grayscale inputs. We built a k-nearest neighborhood model to train the inputs. We built a convolutional neural network based on VGG16 to train with the grayscale inputs. Both produced sufficient results. We are currently working on the implementation of a support vector machine.
Current result for the k-nearest neighborhood model. We generated the result from KNN by first split the data into 70% train, 15% validation, and 50% test. Then we tuned the hyperparameter k to take a model that has the best validation accuracy. Last, we use the model to find the accuracy from the test data. The result from KNN is good, where the best validation score is 0.43 with K equal to 11, and its accuracy on the test data is 0.39.
This is the current result for our convolutional neural network model. This model is designed based on the VGG16. We currently train it for 5 echoes, and this is our current result. The result is promising. Both loss and accuracy graphs show conversion results, and the test accuracy for the model is around 0.5 to 0.6. For the future, we plan to give it different inputs like H-graph, gradient graph, and HOG graph. Our plan is that because H-graph and gradient graph and HOG graphs contain less noise in comparison to the grayscale graph, we expect to generate better results than our current baseline model.
Novel ideas. So we're going to use OpenCV to extract different parts of facial features in the future, such as eyes, nose, and mouth. Then we will use those features to extend our model. We're also going to try different input data, such as edge gradient and histogram of gradient as input. Last, we will try to implement the filter bank using the filters we learned from the CSC420 course, such as horizontal filter, vertical filter, edge filter, corner filter, Gaussian filter.
First challenge we have is to get high quality data. The common data sets about facial expression data sets online are often video clips which are unsuitable for our purpose, and images that are too small, usually around 30 times 30 or 40 times 40. Because our novel points, novel ideas are closely related to feature extraction, we tried our feature extraction on the small images, and the feature we extract are really insignificant and not meaningful. Therefore, we took some time to reach out to different institutes to get quality large images, at least 200 times 200. It took us some time, and we got two really satisfying datasets. It's challenging for us to use TensorFlow model since we are unfamiliar with it. We took some time to learn it from online resources. The same reason goes for why tuning the hyperparameter are hard, because we have no previous experience in machine learning. Finally, since CNN tensor overfit, it also took us some time to look at how to deal with the CNN overfitting problem.
We have learned how to process grayscale or gradient or hog images from the original dataset. Different techniques or filters such as Gaussian blur, edge detection, corner detection, as well as different machine learning techniques such as deep learning, k-nearest neighbor, support vector machine, and convolutional neural network. Moreover, we learned how to utilize different machine learning libraries such as TensorFlow, Keras, and sklearn. And this is the end of our presentation. Thank you for watching.